Okay, here's a picture of the problem. This curve right here is the graph of y equals 1 over x to the fifth. These numbers are actually really small, so this is in a large diagram. This is the line y equals -5. I kind of have that negative in the wrong position. Let me put the minus sign here. And you're supposed to use the washer or the disk method. The washer method implies that there's kind of a hole in the middle. So when you're using the washer method, you want your typical washers to be perpendicular to the axis of revolution. So this is the line y equals -5. And these typical washers, again, are going to occur on the interval from 3 to 7. And what we want to do is have an expression for the outer radius, square it, minus the inner radius, square it. So this blue strip is a typical outer radius. It's the distance from the axis of revolution to some point on the curve. And this point here, for each x, is 1 over x to the fifth. So this distance right here for every x is 1 over x to the fifth, the y coordinate at the top, minus a -5, the y coordinate at the bottom. We're really adding up this distance and this distance. So 1 over x to the fifth minus a -5, that's an expression for the outer radius for every x between 3 and 7, and we want to square that. The inner radius is the distance from the axis of revolution to the inside of the region that we're rotating. And that's going to be the same every time. It's going to be this point right here is x, 0. So the y coordinate at the top is 0. The y coordinate at the bottom is -5. So that distance, this green strip, always has a length of 5. So I could say 0 minus a -5 is 5. So if you simplify all this before you take an antiderivative, we'll square this binomial, which would be 1 over x to the 10th, square the first term, double the product of the two terms would be 5 over x to the fifth doubled is 10 over x to the fifth, plus the second term squared, and then we have minus the inner radius squared. So those two constants are going to cancel out. So here's what we're taking the antiderivative for. And that's the setup of the integral right there. We need to find an antiderivative for x to the -10th plus 10x to the -5. Evaluate that from 3 to 7 and then multiply by pi. So here's what that looks like. Here's the original problem with the outer radius squared minus the inner radius squared. This is 0.0937. Here's after I squared that binomial and combined the two constants. Here's an antiderivative. And if I evaluate that antiderivative from 3 to 7, I get this number right here. But then I have to multiply that by pi to get this answer, which matches what we had on row 1 up here and what we had on row 2. Okay, so I don't know what answer you're expected to give, but I doubt if you want to get a real rational number for that, but you could if you want to do 7 to the 9th, 7 to the 4th, etc. But that should give you the idea, hopefully. And if you have any questions, go ahead and post a comment. By the way, I'm going to send a link to the Desmos graph. But this line really isn't at y equals -5 on the Desmos graph because the picture became too small. So you'll see that this green dashed line on the Desmos graph, if you take a look, is really much higher than at y equals -5.